Welcome to today's masterclass. My name is Lisa Richter and I will be your host today. On the off chance that you don't know about CSIA, we are a global nonprofit trade association with over 500 member companies in 35 countries. For system integrator members, the CSIA Best Practices Manual and CSIA certification are some of the more popular member benefits, but you will also enjoy a variety of others, including professional development, learning from your peers, and access to professional services experts, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. And the good news is that this is actually the best time of the year to join, because as of October 1, companies that join will get all of 2021, the rest of 2021, as well as all of 2022 included in your membership dues and any exchange upgrades or packages. You can get the details at www.controlsys.org/shine. At this time, I would like to introduce today's speakers, Frank and Lewis. Take it away, guys.
All right, thank you very much, Lisa. Thank you, Sandra. So let me go ahead and share. Okay, so thanks everyone for joining us today. Today we're going to talk about the future of factory floor automation. It revolves around a product that we have called EAE, it's our acronym for EcoStruxure Automation Expert. And what I want to talk to you about is the vision of where we're heading and where we believe that the factory floor is heading. And so joined with me today is Frank Prendergast, and he'll have the second half of our presentation where he'll go live with some of the software. And then also on the call is Jerry Bartlemay. They will both, and all three of us will be monitoring the Q&A. So please direct all your questions to the Q&A box on your Zoom screen someplace. And we'll try to answer them as we go through the presentation. Either we'll answer them live with text, or I'll interrupt one of our speakers if it's an applicable moment. So first let me say, when we look at Schneider Electric, there are a lot of users out there that use our stuff today. Whether you're using EcoStruxure Control Expert or whether you're using EcoStruxure Machine Expert, those are our current platforms and they're not going away. But when we look at the future of our business and the future of the factory floor, taking into account the IoT and smart factory and all the other things that we're going to talk about later on, we needed a new software package, and it'll become much more apparent in a couple of minutes. So I didn't want to scare everyone to say, oh, this stuff is going away. It's not. This is a new category of software that customers have a choice to go down. So when we look at Schneider Electric, right, and our competitors all have a similar type of stack. This is Schneider Electric's IoT stack, right? It's called EcoStruxure. All of our businesses adhere to the same stack. We have connected products, we have edge control, we have apps and analytics, and we have a ton of it. But when you look at it, did we really do anything? Did we revolutionize the factory floor by taking our products and putting them into these baskets? You probably have to say no. We really haven't revolutionized the factory floor, and no one has, quite frankly. It's the same products. And so we believe that the future is not the same as the past. And you couldn't say that really when you look at business today. You know, I've been in the business now for over 30 years, and programming PLCs has pretty much been the same. There's been some advances in communication. There's been a change from ladder to the IEC standards. But by and large, there really hasn't changed a whole lot on the factory floor. But in your lives, you're probably seeing a whole lot of movement, a movement from hardware-centric systems to software-centric systems. And that's really what we're going to talk about today, right? Industry 4.0, we've been hearing about this for a number of years now, but on the factory floor, there probably hasn't been a whole lot of revolutionary stuff that's come out when you talk about Industry 4.0. But that's kind of about to change, right? We talk about all the software and the apps and analytics that are coming out. And yes, that's pretty cool, but the PLC stuff really hasn't changed. And so let's look at real quickly an existing system that you have today. And this, again, by and large, hasn't changed. Let me get a nice pointer up here. So it hasn't changed. We have a PLC, we have remote I/O that's out here, and we have instrumentation or devices that are on the floor that are hardwired back to a remote I/O points. And while over time, some of these devices have been connected via Ethernet, as shown here. Really, we're just bringing back a whole lot of data back to a centralized PLC. The I/O is dumb. It needs to grab information from the device. And there's a lot of feedback that has to go back and forth. It hasn't changed a whole lot. When we look at the future, oh, by the way, when you look at all these devices and smart devices that we have, we're plugging Ethernet into these devices. And Schneider Electric, if you look at a system today and the amount of I/O that you have today, a lot of it is taken up by motor management, right? Between control of a motor and auxiliary contacts of a motor, or maybe you have speed feedback or something along those lines. It adds a lot of I/O. And what you're seeing are devices today, and an innovative one that Schneider Electric has released is the TSYS Island. And basically it's a bunch of motor starters slapped together and an Ethernet port that goes in there. And you control everything, including your auxiliaries, and then a whole lot of information that comes back. The only thing that's connected to these devices are your power leads. Really a fabulous device. But can we do more, right? Can we go that next step in our journey, right? Let's just pretend for a second, right? We talk about these smart devices and we talk about Ethernet being connected to them. In a perfect world, right? Every device would have an Ethernet port to it. So if you fast forward maybe 3, 5, maybe even 10 years from now, I don't have a crystal ball to understand when that transformation is going to take place. But if you look at all the devices that are out there and they all have an Ethernet port on it, does your PLC look the same as it does today? Probably in the worst case, no, it doesn't. It looks probably a lot like a switch, right? Where you have many Ethernet ports on there and all your devices are connected via Ethernet. It looks a lot different. In the real world, right, we're probably always going to have some I/O that's associated with it, but it looks different. The plant looks different. So to forget the fact that this diagram looks like a cloud, it's not meant to be a cloud. It's meant to be your plant network where all your devices hang off of a network. And it's visible from everyone, right? Everyone could talk to everyone. So today, does it make sense, if we talk about the next evolution, in the IoT world, in Industry 4.0, there's a lot of talk about edge control, moving our control to the edge. And we put our PLCs in that edge control box in EcoStructure that you had seen. But is it really moving it to the edge? I guess so. It's on the factory floor. But can we move it really to the edge, right to the point of where we're doing control? And this is where we want to talk today. This is where we feel that the industry is going. And so today, right, in this particular scenario, if I have a level sensor, for example, and I want to control a drive, this level sensor has to communicate back to the PLC. The PLC runs an algorithm and tells the drive what to do. Same thing if you had some interlocks that are in here or some other devices that had to talk and enable that control to happen. They all have to go back to the PLC and it's sent here. But in a true distributed control, in a true edge control environment, where everything is smart and everything is connected to each other, why do I need to do that? You have to ask yourself, why do I need to send that back to a centralized area? Why don't I just have them talk to each other? Why can't I send an algorithm that says, hey, Mr. Drive, get your level from the sensor, get your interlocks from the instrumentation. And when these two things meet a certain point that I create, turn on, go to a certain speed, whatever. The algorithm actually resides inside the drive. So it's actually pushed to the edge. Well, that's really interesting, right? That's really interesting, right? Now you're putting stuff out at the edge of our plant onto the factory floor. And you say, how can we do that, right? We're so used to creating one software in a certain location, and then it gets distributed. Like, how do we do that? Well, what's enabling these things are standards that are coming to your factory floor. I can talk to you about Ethernet APL. Maybe you've heard about it, but it's a standard, a physical layer of a standardized Ethernet, right? So today, we all think that Ethernet's standard, but it really is not. There's a lot of different things that are missing from the standard, such as hazardous location, power over Ethernet. Wouldn't it be nice to have one physical layer standard in your control system? And that's what Ethernet APL is going to attempt to do. It's an organization that has many different vendors associated with it. You can go out there and take a look at it, but it handles two-wire Ethernet. By the way, two-wire Ethernet that can go 1,000 feet. Two-wire Ethernet that can be, if you have instrumentation out there that has maybe RS-485 that's on there, it can run over those existing wires. You don't have to pull those wires and replace them with Ethernet cables. Hazardous location, power over Ethernet. And so once you create a standard now you can have lots of different devices created or connecting to that standard. It spurs innovation. The same is for control. When we look at control, we have IEC 61499. That's this is not new, but because of Ethernet, because of the other standards that are happening right now, it's getting a lot of attention in the marketplace. IEC 61499 also spurs on this concept of universal automation. And universal automation is exactly what I just talked about, which is being able to send your algorithms out to the individual devices. So EcoStruxure Automation Expert, which is, again, Schneider Electric's product, does exactly this. You program inside the software just like you do today as a single program, but then you take the individual algorithms, the pieces of logic, and you distribute them out to the edge, to the different devices. It looks like a software package just like you program today, whether it's Control Expert or any other PLC software package. The beauty about this is that this is all because universal automation would have many different vendors involved. You're no longer stuck in a ecosystem of whatever vendor you're using. So the software is an umbrella that looks over your entire plant or your facility or your process, okay? But you can put all devices, any device on the network and send it to that control if it adheres to the universal automation standard. That's pretty neat, very beneficial to an end user who wants to use maybe best-in-class products that's out there. Today, you're kind of stuck with, the software is tightly coupled to the hardware, to the PLC, to the control devices that are out there. Universal automation says that it can go to anybody. Once we create the algorithms according to a standard, they can be deployed to any device out on the edge. That's pretty powerful. It spurs innovation. Innovation spurs new products. It spurs new solutions. It allows the customer to choose best-in-class products on his application. It puts the onus on us as a manufacturer to create best-in-class products. It's actually a pretty neat concept. One of the bigger customers, there's a lot of customers that are behind this, even end users. So you may be aware, Exxon is a big, huge proponent of this IEC 61499. They've been for many years outspoken about it. And if you think about Exxon as a company, they have, I'm going to roughly numbers. They have roughly about 40 refineries. I think they have like 39 or something like that. They have, let's say 40 refineries around the world. And if you say that a control system lasts about 20 years, we can argue 20 years, 25, 30 years. For me, the math works really well at 20 years. Exxon has to do a major upgrade every 6 months around the globe to keep their systems current. And for a refinery, that's huge. Obviously, lots of downtime, lots of money, lots of risk. And why? Because at the end of the day, when they start up again, whether it's 2 weeks, 4 weeks, a month later, 2 months later, after they get their control system up and running again, the latest one, it's doing the same exact thing that they did before they shut down. And yet they were forced to upgrade because of obsolescence. And so intellectual property is already owned by them. They have their plant running. So why do we have this connection between the hardware and the software? Why don't we disconnect this? And so that's what this universal automation is doing. It separates the software from the hardware. It allows people to choose best-in-class products. This is not just a Schneider Electric thing. This is an organization similar to ODVA. Everyone's heard of ODVA out there. It's a separate organization run by many different vendors that are members and that form the direction of the protocols that are a part of that. Universal automation is the same thing. The launch of universal automation is probably about a month away. But it's made up of founding members. Schneider Electric is a founding member along with other manufacturers. It's part IT, OT vendors are a part of it. As you can imagine, a lot of this is IT related. Top users like Exxon, for example, food and beverage companies, pharma companies, all part of the universal org. And then obviously universities are also a part in studying this and seeing how it could be play a part. So more is coming in November regarding this, but lots and lots of benefits associated with it. I'm not going to go through each one of these. That's not why I'm here today, but there are a lot of benefits around universal automation and for you. Now, let's look at Schneider Electric and our offering today. So our initial offering is wrapped around 4 different platforms. One is our ATV DPAC, which is our drives. So we can put control on the edge into our drives. They control I/O and other devices. We have an M251, it's a smaller, lower end PLC, distributed I/O head based on the TM3 I/O line. We have our M580 DPAC, again, based high performance X80 I/O. And then we have a soft DPAC, which will run on one of our IPC boxes, or it'll run on a server. It can run virtually, right, in a virtual machine. Highly integrated, highly flexible, and very fast. And you'll say, well, why a soft DPAC? Well, believe it or not, we have customers, and everyone is different on this line, right? Whether they want to go into smaller nodes or to one larger node to control their plant. We have customers that they come to us and say, hey, I wish I only had one PLC that could run my entire facility. I don't want to have multiple processors out there any longer. Seems opposite of what you would want to do maybe, but certainly you can do that with a soft DPAC. Now you're putting your control into server rooms. You can virtualize it. You can have, you duplicate it, right? Hot standby type functionality. So this is coming. So those are the 4 platforms that we have. The whole thing is to drive engineering efficiency, drive operational effectiveness, and to future-proof your investment. So again, if you're using best-in-class products, you're not stuck to a single vendor. As a new product comes out that has features that you really would like to take advantage of, you could use it. And that's really what a whole lot of advantages are. So we're going to go through, and Frank's going to go through some of this stuff, right? So by the way, this EAE product is not just control. It also has built into it. It has HMI. It also has historian built into it. So a very DCS-like platform, but built around the PLCs. It's object-oriented programming, single-line engineering, simulation and virtualization, edge computing. We can talk directly to right from the factory floor right up to the apps and analytics layer and not have to go through any kind of middleware. Let's see, and then future proofing, we talked about that. So again, driving towards effectiveness, right? Decoupling the software from the hardware. So today, if you're looking at, say, I'll use our PLCs, right? If you're using our PLCs, they're very tied to the software. You can't use Control Expert without using, a Modicon PLC. It just doesn't work. They're tied together. But in the future, they won't be tied together. You'll have the application, which will be EAE, and then you use your best-in-class hardware down on this side. We actually hope you choose Schneider Electric. We hope you have best-in-class hardware for you to use, but that would be up to you. So a couple of things that we want to introduce to you before we get into, Frank goes into it. It's something about a cat, and he'll go into the definition of the cat object model. But basically, a cat is it's an object that has not only your control, but it has all your object properties, it has your documentation, it also has your visualization associated with it. And so you're developing everything at the same time. If you're not making use of the visualization inside EAE, that's fine. Then you're just going to be working on the control side and maybe the object properties that are associated with it. Allows you to very quickly and easily duplicate your algorithms. Driving towards 100% efficiency. Again, object-oriented programming is all about that. It's wrap and reuse the automation objects that we have within a project or over multiple projects. By the way, we're bridging that divide between IT and OT when we go to this system because you're taking data and you're going directly up to the apps and analytics layer. And we'll show you that in a second. So these cats are pretty interesting. So today you look at, when you're programming, you have your lines that go between your programming objects, your code. And typically that's a digital input or digital output that you're passing back and forth between your control items. But a cat is more than that. A cat has the control items built in. And so these lines that I'm passing between cats is actually a pipe. And that pipe holds all the information. It passes all the information from cat to cat. So all your devices can make use of that information. Where that becomes apparent is when we start to look at our products and how they connect them and you distribute them. Remember, we're programming this software as a single package, and then we distribute the control out to the different devices. In this particular case, I'm distributing my control out to a drive, an ATV D-Pack, a 251 D-Pack, an M580 D-Pack, and maybe I have a soft D-Pack that's out there. I program them all like they were one package. I had cats that go to, from one to the other and passing data back and forth. And then I distributed them at the end. Told them where they should go run at the end. The beauty about making these connections with a pipe is that wherever I distribute them, you don't have to worry about the communications. The software does that already for you. And by the way, it passes all that information. It makes that connection so that the system is already connected. So in this particular case, I have a soft D-Pack that makes a connection from cat to cat out to the M580. These data points are connected. The logic in here is automatically connected. You did not have to write a single bit of communication code to make this happen. If for some reason down the pike, I have to split this M580, maybe the logic became too much for a single controller, or maybe my process changed and now I want to put distributed control in a different area. Maybe it duplicated, and now I want to split some of this logic up. No problem. I have my software. I take this logic and I say, you know what? I want you to deploy to a different location. That that cat will automatically deploy to a different PLC, and the communications will automatically follow it. Again, you don't have to do a thing. Again, the beauty about this is that now I can have a soft DPAC, right? It sits right in an edge compute device, which could be a PC, an IPC, a small industrial node that sits on your network or sits on your plant floor. It can connect to CATs that are connected to software. In this particular case, it's some kind of analytics software, My Data Models Analytics. It pulls data directly. We can write APIs that go and take the data directly from the factory floor. Same thing with business intelligent dashboards. We can put that stuff right on the factory floor. We can put it on your phone. We can put it on pads. But the data comes directly from the factory floor, not have to go through some kind of database or access a database in order for that to happen. So again, just to recap before I pass it to Frank, best-in-class technology, right? We're talking about native object orientation, modular approach. We're trying to be engineering efficient, and that's what it does. We're Industry 4.0 ready. We believe that factory floor is absolutely going to all be Ethernet. Everything will be connected in the plant of the future. It may not be tomorrow. It could be 5 years from now, but it's coming. Smart factory is coming. The demand for information is absolutely coming. More and more information, more analytics, more predictive analytics on our equipment that's out there. And that's going to require a different way of looking at your software, a different way of programming. So if you like this presentation, we do this type of stuff. We have a Modicon users group. I will put this login in the chat in a couple of minutes when Frank begins to speak, along with some other white paper information that you can go ahead and download and read on your own. But we have a Modicon users group where we talk about Modicon stuff. It's an engineers for engineers group, and we're looking at people who like to program the Modicon PLCs. We do the latest, we do product releases. I give marketing just a smidge of time. So they get about 10 minutes of time to talk about what was just released, what's coming out, so you have a good idea of our roadmap. But mainly we talk about technical things, right? We talk about new programming features, modernization tools, connectivity, training, expert advice, tips and tricks, and there's always a single main topic. It could be this particular, like a presentation just like we're doing here today, but past ones have been around OPC UA technology, DNP, advanced Ethernet architectures, cybersecurity. Our PLCs have a ton of cybersecurity in them, and surprisingly, in this environment, not many people are actually using it. I think they're leaving it up to their IT people to protect them. But cybersecurity is here, and we have a ton of some really amazing features coming at the end of this year, beginning of next year, around cybersecurity inside our PLCs. So I invite you to join and get the latest. With that, I'm going to pass it off to Frank.
Thanks, Lou. Appreciate it. Good morning, everybody. Let me share my screen. I'm excited to be able to show you EcoStruxure Automation Expert. And everything Lou had talked about was part of the problem of how we manage a system, right? So it's like you had a central PLC that was more or less communicating to its I/O. That would be one project, for example, whether it's Schneider Software or any of our competitors, right? We're all in the same boat, right? Individual projects for individual PLCs. So when you had multiple PLCs, you had multiple projects. And so really the resistance to go to a distributed architecture was because of that lack of software ability, right? We didn't have the software, it didn't look at the system as a whole. It didn't look at the entire process, all the PLCs, or help you manage it. And so what I'm showing here is our Topology Manager, and this basically shows a small system, right? We've got, let me minimize this here. We've got, control workstation. We've got a soft DPAC. This would be PC-based control running either on a Linux-based machine or a Windows 10-based machine. So it can be any PC, basically. Your control workstation, this would be the build station. Your HMIs that were in the field and you would deploy because the HMI is integrated in, whether it's our native HMI that's built into EcoStruxure Automation Expert or a link to a Viva System platform. So we've got similar objects and graphics already built in. So everything that we've worked with in the past has been a manual process, right? You have one PLC, you're creating your project, then you're linking that to the graphics in the HMI or to the SCADA, right? And so when we look at, and what Lou was talking about, was when we look at the factory of the future, we want to minimize those clicks, right? How we take data and how we funnel data from, from an app and analytic, whether it's like an OSI Pi or whether it's a business dashboard, how we get that data. Typically, you'd have a historian. The historian would be pulling each individual PLC to grab the data. You have to configure the historian for that. And then that puts it into a database. And then you have to link from that database to your app and analytic. A lot of work, right? And so when Lou was showing you the CATs and the CATs being able to transfer that data automatically up, simplifies everything dramatically. So let's show how this, how EAE looks at that today. So when Lou was showing our hardware platforms, right, we have the ATV DPAC, which is that it's a small module that actually inserts inside of an Altivar drive, process drive. So that allows full control. So you can put any logic you want in it. And so the nice part with the CAT model is you have application CATs and hardware CATs. Those are the two types of CATs. An application CAT can run on any platform, whether it's the ATV DPAC, the M580, the M251, a soft DPAC can run on any of those and can be interchanged on the fly. So that was, the first part of the problem was, how do I look at everything as a system? How do I then distribute that load? Like Lou was mentioning, hey, maybe my M580 is getting too overloaded. You don't have to worry about the work required to put in new hardware and then map that logic to that hardware, because it's very easy. And I'll show you that. So when we look at, this is how we manage the overall project, the solution, the system itself, and then how we deploy is done at the DPAC level. So you can then deploy. What I've done is I've got a simulation running. You can have 10, 20, 30, 40, 50 PLCs or devices. They don't have to be, they can be an ATV DPAC or a soft PC. All of those are available. As you can see here, I've got, an M251, an M580, a soft DPAC, and an ATV, just to show. And right now I've got all my logic being deployed into this one controller here. I can rapidly change that. So when we look at the system, when we look at an application, now we're looking at layers, right? Or consider them like sections, right? And this is where the code is. So this is the application code. I'm going to click into one particular layer and take a look at it. So when we look at this, when Lou was talking about CATs, which is composite automation types, they incorporate everything inside them, right? So alarming, for example, is not done at the SCADA side or the HMI anymore. It's done in the controller itself. So that when you build a CAT, you have all of that built in. So for example, this is a digital input, and this also is a digital input. It's a high float input and a low float input. I'm feeding that into a CAT that I made, which is a pump valve runtime CAT. And basically, I can distribute these to whichever controller I want just by going to the mapping. So on mapping, this shows you how you can very quickly change that float from one processor to another processor. So very quickly you can do that. And so when we looked at the factory of the future, being able to have distributed runtimes, and this basically is, this goes on a runtime on a piece of hardware like an M580, M251D. Those run the runtime, we then deploy down to that runtime. So independent of the hardware, that linkage where I connect the high float or the low float to the physical input is done at the very end, and it's completely abstracted. So in order for me to change to say, okay, right now I've got these all allocated to one resource, but I can change this. For example, if I have a problem with that controller and that input point, I can change this to another controller, and then these links become peer-to-peer data. So what we have is the ability to very quickly change where the logic is being solved in which resource, which PLC or pack, and then the peer-to-peer communication of how those are transferred back and forth. And that's done automatically, what Lou was saying. So think of that, you know, in the current day, when we have multiple projects, if we have to transfer interlocking data between two controllers, we'll set up Modbus tables, or we'll do Ethernet IP as messaging back and forth. That's a pain, you know, that's a headache. And it doesn't give us the ability to transfer large amounts of data that IoT 4.0 really are needing, right? So that gives you the idea of the power of the CATs and the peer-to-peer processing. So one of the big things is, so when we look at this layer here, this is independent. So you can see what is mapped, which CAT is mapped to which device, just by hovering over it. You'll also see if you change this over that it shows you when you have peer-to-peer communications. There's interlock blocks that are already made. And when we talk about libraries, those are created, whether it's Schneider or whether it's other companies, for example, they would create these CATs that would basically align with the IEC 61499 standard. Once that's aligned, then these libraries would run on that runtime. So which makes it pretty open. So when we look at the ways to minimize those steps, you know, transferring that data back and forth gets to be simple, and it really becomes quite easy. When we looked at the incorporation of everything inside the CAT, you know, typically what we would do today, whether it's us or, you know, one of our competitors, is we develop the logic and the code in a particular project in a controller. We would then, you know, export that or have a link somehow to the HMI, to the SCADA. We would then have to link the individual tags to the HMI and the attributes on the HMI. So this, with the CAT model, actually gives you the ability to incorporate your own graphics natively. So for example, on the left here, I've got the pump valve runtime CAT that I created, and it's a pretty simple CAT. Now I'll go into it here. Really all it's got is it's got a valve CAT inside of it. It's got some conditioning signaling, and then it's got a motor and then a runtime accumulator to show that. And so this shows that in order for you to, if you have another pump and valve that you want to instantiate it, you basically drag over an instance, you drag over this CAT into a section or a layer, and then you give it a name. Once you give that a name, that refers to all the attributes inside that CAT and gives access to all of it. One of the big features of this is what we call single line engineering. And so single line engineering consists of creating a CAT, and you can nest CATs within CATs, and all of the accessibility within the CAT from all the attributes in the CAT is available. So linkage to the HMI, you don't have to worry about. OPC UA connection. What we didn't mention is in our EAE runtime, it's natively built in to accommodate as an OPC. It's an OPC UA server. So that high level of cybersecurity is there. We offer today, for example, an SL2 level of cybersecurity with EAE. So we have a certificate that you need to trust when you initially set up your system. So that gives more levels of cybersecurity in addition to the functionality that you have today. So when we look at incorporating inside the CAT, you know, I've got these motor valve CATs that are in there, and then I can have a particular HMI view. So when I build a CAT, I've got the alarming that is inherent in the object itself. And then I've got the view that I want to display. And you can have multiple, you would create a symbol, and that symbol can be whatever display you want. You can modify, and what we show here, for example, the motor copy of the motor 1S1D is where our libraries are open to the point that you can take one of our library cats that we made, you can copy it, and then you can change it and modify it to what you want. If you didn't like the colors, for example, in the HMI, if you didn't like the HMI display, if you wanted to tweak it, you can make that your own library. When we talk about libraries, again, this goes to the future-proof concept. So future-proof really is about how we're not tied to the hardware, which is a big part, but then also how we can use the same runtime with different pieces of hardware and still run that same code. So that really makes the future-proof part of it. With your libraries, you can lock in your libraries to a certain version number, and then from version to version, it will port when you want to go to the next version of EAE. You'll take your old libraries that will be locked in your application, for example, or used in your application, and all of that provides all of that ability for you. The peer-to-peer communication is inherent, right? So when you link a cat to a cat, whether those two cats are in the same system or whether it's in the same resource, for example, PLC, these are in the same PLC, so there is no really peer-to-peer, it's all handled within. Change one of these over, automatically that peer-to-peer messaging is taken into account. So let's take a look at the hardware abstraction layer. So there are application cats and hardware cats. Application cats are completely independent from the hardware, not tied whatsoever to the hardware. They can run on any runtime. A hardware cat allows you to, the cat is specific to a piece of hardware. For example, it would be an M580D cat, hardware cat, and that, or an M251D. And basically this, when you install the hardware cats, this gives you the ability to map the IO. And let me see, where's the other one? So I'm going to map, for example, I'm going to add an M580 X bus. Actually, you know what? I'll go back. So this allows you to configure the hardware to say, okay, what IO modules do I have? What, and then after you've done configuring the individual modules, scaling on the modules, all the inherent stuff, then what you're going to do is you're going to link using what we call our symbolic links. And the symbolic links then tie to the attributes in the particular application. So for example, the output of this analog set point is a heat-cold valve. So that can be linked to an output, for example, an analog output. That linkage is what makes it so easy to have a truly distributed system, because you've decoupled the hardware from the software. The only link is that symbolic link that ties the hardware to that. So again, that makes you able to distribute the load very quickly. I mean, think about if you had multiple, let's say 10 PLCs. One of the PLC systems that you have today is getting overloaded, too full with logic. It's slowing down. You need it to be faster. Distributing that logic over to another project, what a pain, right? So you got to manually move from one project to the other, the code. You got to then do the map, the hardware. So it's quite extensive on what you need to accommodate, and lots of mouse clicks, right? So single line engineering gives us the ability to really encapsulate everything in a system so that you can readily duplicate it. So that really makes it so much easier to handle. The IT linkage, what we needed with our new generation of PLC programming with EAE is the ability to look at IT technologies. So how we can very rapidly get access to all different protocols like MQTT, for example. How do we link to a database, call a DLL? We really didn't have that kind of capability, and the existing system that we had today really doesn't really show you that. So the complexity of that, or the lack of being able to connect, really limits the amount of data that you're able to get access to. And so that's one of the things that, for example, we can call SNMP messaging to interrogate devices in the field. We can do MQTT messaging. We can call DLLs to be able to transfer data to apps and analytics. And all of that is something that is built in today. When we look at the model itself, when we look at the application CATs, for example, or hardware CATs, the application CATs link everything together, right? What we mentioned, the archiving capabilities, the HMI visualization, along with the control code, alarming. All of that is done at the CAT level, which makes it simplified. We've got 3 types. We've got a CAT, the composite automation type. And when we look at that CAT, that really gives you everything, which is gives you the offline parameterization, for example, gives you the interface, what input pins, output pins they are. Look at the composite being what's the logic and the code inside. Offline parameterization is kind of like the initial values kind of storage. And then access to OPC UA. So it gives you whether or not you want to expose it to an OPC UA client, for example, or not. So all of that is built into the CAT model. We've then got underneath that, another type of object is a composite type. An example of a composite really looks about the same as what you had with a CAT, except you're missing the offline parameterization and the OPC UA. So that really is the difference between a composite and a CAT. And then a basic function block gives you the ability to run what's called ECC, execution chart control. And so basically, when you look at the interface, you have the input events coming in, and then you have the data. And we'll talk in a second about the input events and how that works. But when the input event comes in, for example, when I get a request input event, it will fire the request algorithm. In this case, when I get an init event, it fires the init algorithm, and the algorithms are here. Now, what we didn't talk about yet is the IEC 61499 is really a superset of the IEC 61131. So inside of the IEC 61499, you can program in structured text, for example. You have that function block programming capabilities. You also you've got, to a lesser extent, ladder. Structures are supported, adapters are supported, all of that. So this gives you an example of what a basic function block looks like. We have service blocks, which are much more tied to the hardware. Adapters, which are when Lou was talking about the pipes, the links between CAT to CAT, an adapter basically is a glorified structure, right? So it gives you the ability to either process and send back and forth arrays, or to be able to give any access to it. When we look at Canvas, the Canvas is the HMI part. And so what I'm showing here is what I created from the logic. Everything except the tanks, these 2 tanks, and the piping are CATs. They're already pre-made. So I didn't really, I created this CAT, which is an accumulation of a motor for a pump, whether it's a motor for an agitator or a motor for a pump and a valve. But basically, this is all done. So very quickly, you can put together a very quick process and automate it. So you have this standard HMI. So I instantiated the CAT objects onto a layer. I then, after I built and then deployed to the controller, then I can instantiate the instances of those CATs that I just made on the screen, and that provides this. And so automatically is, I've already got my pop-ups, for example. I had logic set up to say, if I don't have anything in the tank, shut off the conveyor. So I'm going to keep that running. I've got digital inputs, for example, the low float and high float. Down here is an automatic alarm banner. So the cats embed all of that alarming natively. So all you have to do is drag an alarm banner on. When any of the cats are sensing some sort of an alarm, it'll pop up there for the operator. So it makes it really easy to accommodate any kind of alarming need. So I'm going to put that into manual mode, trigger the low float. That'll turn the agitator on. And I've got interlocks, for example, that are built in. For example, very quickly, just by naming the instances of the block, it will automatically send that data up to the HMI, so I don't have to put in this text. I call this D10 low float condition off, and that basically automatically does that. So again, ways to reduce low value engineering is a big part. Ways to be able to link this information to data, so your visualization can link into other type devices. So all of that is all incorporated. When we trigger the high float, turn that on, then I'm going to have my pump and valves basically start pumping. So all of that is done automatically. So very quick to instantiate. So when we look at the link to the HMI, what I showed here is the native HMI that's built in to EAE. We also have, if you have a Viva system platform, we have the ability to, you make a connector, and the connector makes that connection over to the individual objects that are already part of a Viva system platform. So again, very quick to link your visualization to your individual items. Let's see, we're getting close to the top of the hour. I think we want to leave a little bit of time for some questions. I see there is some questions in the chat.
I do have a question here, Frank. So it says, interesting idea, but I'm having trouble seeing the difference in this system and a plant-wide DCS with multiple processors, i.e. Delta V, 6net. Would this be an open IEC 61499 alternative?
So there's a couple of answers to that. Great question. The first is that this is very scalable. So what DCSs are great at is humongous systems, right? 100,000 points of IO, tens of thousands of field bus devices, large, really large systems. This can be as scalable as one small controller to 40, 50 controllers, for example. So I see, for example, we have Foxborough DCS with Schneider, right? Great for those large end systems, those really big systems, but it doesn't necessarily, DCS doesn't really scale down to the small side. And so this is really designed for the small side and the medium side. And then with regards to your question about the open standard, yes, so any device, any piece of hardware with the EcoStruxure runtime, this can be deployed to. And then the linkage would be done by a hardware cat. Hopefully that answered your question.
Yeah, if I can add to that a little bit on the openness, the concept of universal automation, as Lou presented it, really tremendously opens things up, because now you've got multiple vendors that all support the same runtime. So literally any device out there that adheres to that standard could be made a part of this system. And so it really unlocks the vendor lock that you have here, especially in DCS systems. They're famous for that.
Yeah, great point, Jerry. Any other questions, Lou? Or?
No, there's no other questions. Let's see. So I guess I probably have just, we'll probably end on this. This is, we're getting towards the end here. There are probably some of you that are out there and saying, you know what, this is probably never going to happen, blah, blah, blah. And for those, I would say that when you look at your systems today, And you let's look at your personal life, for example. Look at your home. And 5 years ago, 10 years ago, there was nothing smart inside your home. And today, you can't go and buy appliances. And I just did that, as a matter of fact. Almost all the appliances today have some type of connected devices to them, right? You can connect your refrigerator, your stove, your oven, your microwave, all that stuff gets connected. Well, you can argue why I need that. That's fine. But the factory floor really has not undergone that type of revolution ever, right? It's pretty much the same for the last 40, 50 years. Hardwired I/O. We've had a couple of Ethernet things. We've made some changes in the IEC languages to make things better, but we really haven't undergone that tremendous change. And the time is ripe for it. So if you look at all the environment, the things that have changed on the factory floor, the proliferation of Ethernet, for example, everywhere, the standardization now with the Ethernet APL, the way we can communicate to all kinds of devices, it just lends itself for that next step. Is this going to happen tomorrow? I want to be clear. It's probably not going to happen tomorrow. We all know, and end users, right? It takes a while for that to change over. Nobody's got endless amounts of money to go ahead and change over. But that slow progression towards the smart factory is absolutely happening. We talk with customers all the time. We ask them, hey, what are you guys doing around smart factory? Do you have people that are dedicated to it? And they do. They have meetings around it. Some people don't know where to start. It depends on where they are in their journey, but some people don't know where to start. They have a committee that sits down and they have made the move and doing some evaluation. In fact, I've been pretty impressed with some customers of how far down that journey they are. And the same thing with our company. We've gone down this journey, and but this is a part of it. This is happening, and it's ripe for this universal automation, for moving the control to the edge and creating a true smart factory, vendor agnostic almost system that's out there. And if you think about it also, and I'm just going to leave the part with the need for standards creates, again, I talked about it before, it creates innovation on the factory floor. The reasons why we all don't have a camera on our television, right, to be able to call grandma or mom and dad and stuff, is because there's no standard. There's no television manufacturer that's going to go ahead and make a standard because there's no way to actually make that connection happen. And on the factory floor, we look at that. That is starting to happen right now, to make those connections to all the devices, to bring it in, to have one standard to communicate. So I want to thank everyone for joining us today. It's been a really great session. Feel free to reach out to myself or Frank or Jerry for more information if you'd like. Feel free to join the Modicon users group, and we'll answer as much questions you have. So I have one last question here. We have a minute or two. How do you see the adoption of IEC 61499 across the ecosystem? Open platform and automation is a new concept, but how fast can we see progression overall? So I guess I could probably answer that. I think it's kind of what we were talking about. The progression will be slow but steady. That's my opinion. That's a Lou Arone opinion. Schneider Electric is investing a lot of money. We believe that we're going in that direction, and there's a bunch of other companies also investing in that universal automation concept. So just like any other standard, it takes a while. The organization, the Universal Automation organization, third party, run by many different manufacturers, it's getting off the ground shortly. Adoption standards need to get developed. It's going to be years, a few years before that happens. But I think there's this slow progression moving towards this universal automation.
I do think that once universalautomation.org is opened up and you have access to it as a platform, you're going to see just how many companies have been invested in this for how long, and there's actually a lot of effort going into this standard today.
Thanks, guys. Sandra, will you please put up our final slides? There we go. On behalf of CSIA, I would like to thank Louis, Frank, and Jerry for this informative discussion. I'd also like to thank Schneider Electric for sponsoring this event, and of course, thank you for attending. I'd also like to remind you that a recording will be available for viewing within the next couple of days. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. This concludes our program for today. Once again, thank you for joining us and have a great day.